So first and foremost, when you have your warm-ups, I would always put the date. And I would put whatever it is that we're doing. So at the top, I would have warm-up 8/21/25 fractions day 1. Because you might come up during a test and say, Mr. H, I'm struggling. And I might say, hey, this might be in your warm-ups from, and give you a general idea of the date range. So you can go back and find it. Does that make sense? I'm going to help you, but I want you to help yourselves first. You're all becoming now, you're not kids anymore. You're becoming young men and women who are not just getting ready for high school, you're getting ready for the real world. I want to prepare you for that. My goal is not just 9th grade math. Okay? So, I hated word problems as a kid. I'm going to be cocky right now. I am not a teacher who teaches math. I am a mathematician who teaches. My college degree is in mathematics. My SAT scores, my collegiate stuff, 9 times out of 10 when I walk into the room, I am the smartest person in the room. 9 times out of 10. When I'm with my wife, never. She is, again, rocket scientist. She's much smarter than I am, like truly rocket scientist. So she's much smarter, but 9 times out of 10, I'm the smartest person in the room. When I saw word problems as a kid, I immediately tried to solve them. Can't do that, okay? Because I look at the question and then just try to pull stuff out. And I know it sounds silly, but the first thing you should do in a word problem is read the entire thing. That way you know exactly what the, like, extraneous, you know what extraneous means? Extra information is. So it says, Mr. H deadlifts 455 pounds 8 times on Monday, 2 sets of 4. Bench presses 225 pounds 30 times on Tuesday, I did 3 sets of 10. Back squats 375 pounds 5 times on Wednesday, I did my 5 singles. And strict shoulder presses 165 pounds 15 times on Friday. How many total pounds did Mr. H lift throughout the week? So now we've read it. Our brain's starting to process. Step number 2 in a word problem. What is the question asking? What's the question asking?
How many pounds total?
How many what?
How many pounds total?
Total. I'm making sure that you get that. So how many total pounds? So now that we know the question, we really need to ask ourselves, so step 3, what does that question want? Because it's going to want one of 4 mathematical operations for us to add, subtract, multiply, and divide. What does the word total mean?
In all.
In all, good, yeah. But what mathematical operation? Add, subtract, multiply, divide.
Add.
Add. What's another word for add that's the answer to an addition problem?
Sum.
Sum. Very good, Ben. Air 5. Psh. You missed a little bit. You like hit my shoulder? Here's my hand. Over here. Psh. Okay. No, you just touched me with like a, okay.
The scissors beats paper.
Let's try again. There we go. Good. Okay. So, sum, total. You've heard those words. Sum means the answer to an addition problem. So we're going to be answering an addition problem. Well, what are we adding? Where are my markers? I know it. Wait, you can answer that question. You've been like, I'm not going to answer any of the math questions. Thank you. You can answer any of the math questions?
Yeah. If I know them.
Nope, calling on you when you don't. It's going to be great. So, total throughout the week. Abby, how many days do I need to add up? Say the days. What are the days written in the problem?
Monday,
Plus,
Tuesday,
plus,
Wednesday,
plus.
Friday.
Good. Okay. So we're adding 4 days. But now we're looking at the problem. What did I actually do on Monday? Go ahead.
Monday you deadlifted 455 pounds 8 times.
Okay, so what do I have to do for Monday to find the pounds though?
You have to do 455. Is it times? Yes.
Times?
8.
Okay, so we're gonna do a lot of different things. So you said 455 times 8. I'm not gonna do that. I'm going to do 8 times 455. I gotta keep my street cred, 55. Okay, so 8 times 455. Why can I switch multiplication? Does anybody know what that property is called? You don't have to. It is called the commutative property. It says if I have 3 times 4, which is 12, I can multiply 4 times 3, which is 12. So 455 times 8 is the same as 8 times 455. I personally like putting my smaller number on the outside. Everybody good with that? Okay. Abby, what am I doing on Tuesday?
30 times bench pressing 225.
So 30 times what?
225.
Beautiful. 30 times 225. Yo, Mr. H, I got a problem. Yeah? I have a number next to a parenthesis. Seems simple to me because I know what it means. You probably know what it means too. Anytime a number is smack dab up against a parenthesis, it means multiply. I'm going to say it again. Anytime a number is smack dab up against the parenthesis, it means
Multiply.
Okay, I'm going to say it one more time. Anytime a number is smack dab up against the parenthesis, it means Oh, I'm so glad you guys know. Don't give me that look, Caleb. You're like, I hate this class already. It's all right if you hate it, you just can't show it on your face. Okay.
Yeah.
So, it means multiply. Wednesday. Ben, give me Wednesday.
On Wednesday,
Yep.
he back squats 375 pounds or LBS 5 times on Wednesday.
So what am I writing? I want to know what I'm writing.
375
Uh-huh.
in parentheses
Beautiful.
and 5.
Beautiful. So we're taking 5 smack dab up against the parentheses, which means what? When it's smack dab up against the parentheses?
Multiplication.
Multiplication. Last but not least, enough. What's Friday?
165 pounds.
What am I writing? I want to know what I'm writing.
Oh.
Not what it says. We already did that part.
So in the parentheses, 165 pounds, and
Beautiful.
then outside the parentheses is 15.
Good. Okay. So we're there. Hey, y'all. Notice how there's no equal sign. Oh, excuse me. I'm sorry. Ugh. That was horrible.
Why do you
Don't.
have,
Don't. What, Ben?
why do you have so many cups?
Because this was my Christmas gift from my kids every year. So it's pictures from when my son was born, to when he was 1, to when my daughter was born, to when... So it's every year. So I will have these every single year. It's the only Christmas gift I ask.
Why is there a paper on the cups?
Because this morning, my son made a little basketball hoop and saved these as the basketballs. He said, that way, Dad, you can play basketball later, but it fell off and I had to throw it away. So that's from my son. Good question. Okay. So there is no equal sign because it is not an equation. Remember, I'm a mathematician that teaches. I teach math like a mathematician. It's like a language. If you can speak the language, you're going to be able to do it. Okay, I'm not saying that some people didn't necessarily know how to speak math. I do. No equal sign, no equation. What is it called when there's no equal sign? When it's just numbers, variables, and mathematical operations. It starts with an E.
Equation.
Okay, so we just said that it's not an equation. So it starts with an E, ends in expressions.
Equivalent?
Yeah.
No, it starts with an E and ends in expressions.
Equivalent express.
expression.
Expression. It's an expression. Oh my gosh. Guys, starts with E, ends in expressions. Expression. It's an expression. When there are just numbers. Oh my god. Guys.
No.
That almost landed. That would hurt. It is an expression. So when it has numbers and mathematical operations, adding, subtracting, multiplying, dividing. Okay? It is an expression.
Expression.
Very good. Okay. Holy crud. How close was that to hitting me?
Very
Like
close.
really close.
Oh,
It hit my
I
hand.
remember.
I'm glad you remember. I just said it. Like, do you remember from just like 20 seconds ago, or you mean from last year?
From last year.
Okay, fair enough. So, when we have an expression like this, we need to either simplify or evaluate. In this case, we're simplifying because we already have the numbers. When we evaluate, we substitute something in. So we are going to simplify this expression. When we simplify expressions, we follow the order
Of operation.
of operations. Very good. Who remembers the letters?
PEMDAS?
PEMDAS. Love it. It's wrong, but I love it. That's what most teachers teach you is PEMDAS. It's not. It's GEMDAS. Because it's grouping symbols, exponents, multiply, divide, add, and subtract. Because it's not just parentheses. It's parentheses, it's brackets, it's square root symbols, it's absolute values. You're raising your hand.
How do you spell GEMDAS?
GEMDAS. But you don't need to know that now because this isn't the lesson. This is just our warm-up. We will get to this in about 2.5 weeks. I just want to see what you remember. That's all. So, guess what? We have grouping symbols. Is there anything to do inside of the parentheses? There's just a 455, right? There is nothing to do inside of the grouping symbols. Therefore, we don't have grouping symbols. We don't need to do it. Are there any exponents? Exponents are like something like 5 to the 8th, right? None of those. Is there multiplying and dividing?
Yes.
Yes. We do multiplying and dividing in whichever order from left
Correct.
to right. It's just like reading. Math is just like reading. You need to go left to right. So we are going to multiply. I need you guys to double check my work because I don't have a calculator. So get your calculator. We are doing 8 multiplied by 455. What is it?
3,640.
3,640. Beautiful. Plus. Then we need to do the next. Abby, will you do this next one for me? 30 times 225. I think it's 6,000 something.
It's 6,750.
I'm sorry, what is it?
6,750.
700 what?
50.
700 what?
Oh.
50. Keep your street cred. 50. You want to try it again? Okay. T.
1,970 feet.
What? 1,900 what?
70 feet.
Just 70. You can only do
Oh.
it. You can only do it with 50. You can't do it 70. That's
I thought.
all right. You're good. Is that the right number? Just double check it. Yes. I don't think it is.
It was 75, I think.
Was it 75?
Yeah.
Okay, I thought so too. Okay,
I had 1,800 or 1,800 was like that.
double check it. So 5 times 375.
Oh, that's where I did it wrong.
1875. So not 9. 18.
Oh, yeah,
Good.
that's why I put 18.
Okay, so that's why we're double checking. Listen, I'm going to make mistakes in this class. Y'all are going to make mistakes in this class. I would rather you raise your hand. Listen, there's 5 of us. We're not going to be mean to each other, but you can say, hey, I don't think that's right. Can you double check it? And I might say, sure, tell me what you did. Or I might say, I'm wrong. Yes, sir.
The one, I realized that the one I got wrong was the first one.
Gotcha. So now we have the last one, 15 times 165. Go ahead.
Is 75.
2,475.
Yeah,
Okay.
I'm sorry.
So we've now done multiplying and dividing. Once again, now we are to the next step in order of operations, which is add and subtract. We can get all of these and add them, Massfields. Thank you. So we're going to add them all up, and we should get this number here, 14,740. Love that. You answered very well. Closer. So, what's wrong with my answer?
It doesn't have the LBS.
It doesn't have pounds because this is a word problem. Therefore, I want words. I am big into making sure that we do math and science correctly. Again, my wife and I are STEM people. You know what STEM is? Like, it's big in technology and math and all that. We're teaching my son, who's 7. He could come in, no kidding, and do most of algebra because I taught him all summer. Like, he's graphing linear equations. He knows negative and positive numbers. He could come in and teach you why a negative is a negative. Like, it's silly. Because we're being very specific with it. Math and science requires specificity. The question says, how many total pounds did Mr. H lift throughout the week? The answer needs to say 14,740 pounds lifted in total. And that's still not completely specific. It should say Mr. H lifted 14,740 pounds total throughout the week. That would be as specific as we possibly could. But anytime that I have a word problem, I want something. Would I accept pounds? Sure. But I want it to be as specific as you can make it. Questions? How do we feel about this?
Good.
Easy-ish? Okay. Our first several weeks, week and a half, 2 weeks before our first quiz, is reviewing stuff that you need to know before this year. Okay? So this isn't algebra. It's what you learned in pre-algebra, taught by me. Fair enough? Yes? Okay. I'm going to erase this. Does everybody have it? Am I good?
Yes, sir.
Yeah.
I am an East Coast guy. I grew up in Pittsburgh, Pennsylvania. That's why I have my terrible towel over there. Okay? I talk fast. I know that I do. You got to say, hey, Mr. H, can you slow down a little bit? Absolutely. I'm here for you guys. Don't be afraid to be like, I don't know what you said. Okay? I had a young lady last year who copied notes so perfectly that it was amazing. Like, it was better than a printer, but she took her time. So I would say, hey, at first she's like, wait, don't erase that. And eventually I learned. So I could have two problems, do the third, and even though I can go back to the first one and erase it, she's still copying down the second one. So if you need to take your time, let me know, okay? I'm here for you guys. Everybody with me?
Yeah.
Okay. So now you're to notes. I would put the objective somewhere. Where is it? That's not it? Where are we? I can add and subtract fractions and mixed numbers. That is our objective. We're probably not getting to it today. Okay? Because I don't even know what time this class ends. I think 2 o'clock? I don't know. Oh, 2:05. I got all kinds of time. You're not going to have homework today. I'm going to give you homework tomorrow.
Okay.
Okay? So, we are on fractions day 1. A fraction is a blank problem. Besides being stupid and a math problem, those aren't the words that I'm going to look for. Okay? I like to base things off of the 4 mathematical operations. So adding, subtracting, multiplying, dividing. What is a fraction? What type of problem? Is it an adding problem? Yeah, say it.
Divide.
Yeah, it's a division problem. A fraction is a division problem. Okay, we all good? So, the bar, the fraction bar, is the division symbol. Okay? That's what's telling us that we're dividing. No problems there, right? We should know that. Mathematical language. What are the parts of a fraction? Give me the top part.
Numerator.
Numerator. Caleb, were you at Mr. Kelly's last year? Bottom.
Denominator.
Very good.
Wait, is that what the dots stand for?
The dots, yeah. The division, yep, can be written as a fraction. Okay? I like it. You're like, yeah, putting connections. I'm going to label this as N and D for a second. Because this fraction is truly the denominator going into the numerator. Okay? So this is long division, yeah? You've done long division before. You're not going to have to do long division because you've got the calculator. You're not going to have to do it. Okay? So the denominator goes into the numerator. Everybody's still with me? Somebody say example 1 for me. How would I say that number?
3/4.
3/4. 3 divided by 4. This truly means 4 goes into 3 how many times? So we could do long division. We add the decimal comes up. 4 doesn't go into 3 at all. So now we're going into 30. It goes 7 times. 7 times 4 is 28. That leaves me 2. I add another 0. 4 goes into 20. 5 times 4 doesn't leave me a remainder. So 3/4 is, how would I say that decimal? Because 0.75 is not correct. 75 hundredths. Okay, 2 decimal places is hundredths. 1 decimal place is tenths. Okay, so this is 75 hundredths. This is a fraction. We also have what are called improper fractions. What makes something an improper fraction?
When the denominator is, or when the numerator is higher than the denominator, or
The numerator's always higher. See how
I meant
it's
the
above?
Yeah, the not.
No, the numerator's above and it's higher.
Yeah.
What do you mean by higher?
Greater number.
There it is. It has a greater value.
Yeah.
Okay? I know, you're like, I said that. I'm very much about using the right language. So, let's do something like this. 7 in my numerator is a greater value than 5. How would I say this? Somebody else. You know?
7/5.
7/5, very good. So 7/5 truly means how many times does 5 go into 7? Now, when we have an improper fraction, that means there will be a whole portion to it. What do I mean by a whole portion? Well, the number to the left of the decimal. Okay? So, can 5 go into 7? Yep, once. 1 times 5 is 5. That leaves me with 2 remainder. Well, we know that we can add a decimal and a 0. The decimal comes up. The 0 goes down. 5 goes into 24 times. 4 times 5 is 20. So, 7/5 as a decimal is truly, how would I say this? Want to try it?
1.4.
Okay, so we're not going to say point.
Oh,
1 and
1.
4 what?
4.
So this was hundredths.
1 4/5. Wait,
Well, not
1
fifths.
400s.
4 goes smaller than hundredths. What's the one smaller than that?
Tens.
There it is. So say it.
1 4/10.
Very good. Awesome. 1 decimal is tenths, 2 is hundredths. And we're going to work on this. Listen, this isn't something that a lot of teachers emphasize. Most teachers will say it's 1.4. And listen, there will be times where I'll say it's 1.4. But right now, I'm going to try to teach you the correct methodology. Everybody with me? So we have fractions, we have improper fractions. We will get to mixed numbers. Well, mixed numbers really are improper fractions. Okay? A mixed number and an improper fraction are the same thing, they're written different. When it has the same value but written differently, they're called equivalent. But we're going to get there. What do I want to talk about today, though? How to simplify. Move this a little bit so we can see. I might be able to see that. My water is. Does anybody need a break? Does anybody need to shake it out, stand up, do anything? Class is going pretty quick for me. I don't know how it feels for you. So, you guys gotta let me know. Okay, so how to simplify. Simplifying a fraction means to get it to its smallest part. So an example would be like 8/10 is really 4/5. When we simplify, we are looking for equivalency. Has the same value if you divide it in the calculator, but looks different. Equivalent means has the same value, but looks different. There are several ways to do this. The first way, if your ones digits are even. Even numbers, 0, 2, 4, 6, 8. Even numbers are 0, 4, let me draw out, Mr. H. 0, 2, 4, 6, 8. If your ones digits are even, then you can divide by 2. Let's have an example. Okay? This is going to be these rules here. I would suggest putting on a separate piece of paper and being able to pull it out of a folder so that you can have it on quizzes and tests. Okay? You're going to want to be able to utilize this a lot. So, let's do this example. Let's go 12/10. Okay? This is not in simplified form. The ones digit, the 12, the 10, my ones digits are 2 and 0. Those are even. Everybody still with me? Which means I can divide both the numerator and the denominator by 2. What is 12 divided by 2?
6.
6.
6, good. What is 10 divided by 2? 5, beautiful. This is simplified. These are, they are improper, good. but they are equivalent. Equivalent means has the same value, looks different. Can I see your calculator again?
Yeah.
We're gonna work together. So 12 divided by 10 is 1 2/10. 6 divided by 5 is 1 2/10. Clearly, they look different, right? But they have the same value. That's what equivalent means. Okay? This is the hard one. This is going to be the hard one. If the sum of each number is a multiple of 3, then you can divide by 3. That shouldn't make sense when you read it. It's fine. It should not make sense when you read it. That is fine. It should not make sense when you read it. It says if the sum of each number is a multiple of 3, then you can divide by 3. It doesn't need to make sense yet. Wait for me to explain it. My example is 12/27. Watch what I'm going to do here. First off, a multiple means I can skip count. Have you ever skip counted before? 2, 4, 6, 8. We can do the same thing with 3. 3, 6, 9, 12, 15, 18, 21, 24, 27. Those are multiples of 3. Sum. You told me what sum was. What was it? You told me what sum was. The answer to what type of problem?
An equation.
An answer to a, what did we say total was?
Addition total.
Yeah, so the sum is the answer of an addition problem. Well, what are we adding? 1 plus 2 is?
3.
3. Is that a multiple of 3?
Yeah.
2 plus 7 is? 9. Is that a multiple of 3? 3, 6, 9. So what can we do with these? Divide both the numerator and denominator by 3. 12 divided by 3 is 4. 27 divided by 3 is 9. Once again, what are they? They are equivalent. Okay, ready?
Yes.
Making sense so far? Because you're going to need to simplify fractions. I will not accept answers that are not simplified. We got 2 more. These are the easy ones. And this is why I would suggest putting them on like one separate page so that you have them, even if it's a small little index card. So 3. If one's digits are 0 or 5, then you can divide by 5. Okay? Easy, yeah? This one you've been doing for a while. Do you have that? Nice. So let's say we've got our example, 35/45. So once again, one's digits. 5, 5. Is that a 0 and a 5? Sure it is. Which means we divide both the numerator and denominator by 5, which leaves me 7/9. Once again, these are equivalent. Why? Because they have the same value, but they look different. Okay, everybody still with me? Long lesson today, I'm sorry. Last one. If both one's digits are 0, then we divide by what? Both are 0. We can divide by what?
0.
We never divide by 0. Good guess though.
And
No? Okay, sorry. That's what I'm teaching you guys. By 10. So, last example. 70 divided by 30. The ones digits are both zeros. Therefore, we would divide both the numerator and denominator by 10. When we divide something by 10, if they already have zeros, you can just cross out that 0, the last 0. So that would become, as I cross it out, 7. As I cross it out, 3. Hey, I know this is going to come as a shock. 70/30ths and 7/3 are what?
Equivalent.
Equivalent. Okay, that's it for the day. Now listen, I know you all are like, man, he has said the same things over and over and over again. Does he think we're stupid? No. Okay? It takes repetition to learn. So you will see me use the same verbiage. Numerator, denominator, equivalent, trying to get you to use that math language so that you feel confident. I don't want you to leave this class ever and going, I have no idea what just happened. Everybody with me? Hey, great job today, guys.
Who's your